Now we can go ahead and open Microflow CFD. Here we can insert diffusers, grills, and components such as people and furniture. To add a diffuser or grill, we need to select our ceiling or wall and go down 2 levels. Here we'll have access to our boundary condition. From the dialog box, we can add our flow and change the units if we wanted to. So let's add 250 CFM or 0.12 meter cube per second. And we can change the leaving air temperature here, which you can calculate if you have your space load and your CFM and your set point. Here's the calculation that we use for heating mode and cooling mode. Let's go ahead and input, let's say 26. And we can go ahead and plot our diffuser size. From here we have a few options. We have a general supply, which is closest to a laminar flow diffuser, a two-way which can discharge air in 2 directions in the vertical or horizontal direction, 4-way which is closest to your square plug diffuser, and swirl which is similar to your radial types. And of course we have extract for return and exhaust grills, temperature for a fixed temperature emitting element, heat acts as a constant heat source on a surface, and a fan is pretty straightforward. Pressure is what we can use as an air transfer while maintaining a pressure differential. So you can have a typical 0.2 inch water gauge separation between a corridor and, say, a lap space. And you'll notice at the bottom of the window a section called flow balance. It's there because whenever we run a CFD analysis, we always have to have our total flow equal to 0. If we want to add pressurization and we want to have a difference in supply or return, our only option is the pressure boundary. You could leave the flow balance as positive or negative. The pressure boundary will balance the system out automatically. Porous baffle I personally never use, but you could use it on an opening or a hole to limit the available face area. Let's go ahead and add another 4-way diffuser. Let's make this one rectangular. And you could also edit the discharge angle, although for a typical square plug diffuser you could just leave that at 0. Let's also add an extract. And once we're done drawing our grills and diffusers, we can modify them in the same way that we could do windows and doors. So if we highlight an extract, and you could see it's highlighted on the left, you could add construction lines. And you have the same tools to move or copy our extract. Let's say I want to have an extract on the wall. Let's go ahead and delete that one and go back to our space. And if you expand the ceiling tab, you could see all the grills and diffusers that we placed. If we want to add one on the wall, we can select it, double click it and go down a level. And it's the same way where you could add the extract and modify it however you want. And now you have an extract on the wall that acts as a low level exhaust. Now, if at any point we want to modify the airflow or the leaving air temperature or the airflow direction, we could click on the diffuser or grill and edit it from down here. And now we're ready to start adding components into our space. So now we can go into the components application, and from the top panel, click on components and import gem files. Go ahead and select your gem file and open it. From the components application, we can modify and create new components. You have access to modification tools just like with Model It, although I highly advise not creating your own components and use the standard library that comes with IES. To import from the library, go to the Components tab, Add from Library, and then here we have access to a whole bunch of components. You could click the preview on the right to see what the component looks like before we import it into our model. So let's add a chair, a desk, import into our model, and now let's add that to our space. go to the Marketflow CFD, go down to the space, and we should have access to the Components tab. So only once we go from the axonometric view to a plan view, we can place our components. So here you'll see a dialog box open, and we have a few types of components that we could add. We can add the radiator, and we can edit the size here, and we could have as a source of temperature or heat if we want to. So let's do 200 watts. And for the plan elevation, I would suggest going slightly higher than 0, just to avoid it intersecting with the floor. Let's go ahead and place that, see what other options we have. We can add an operating table, we can rotate it if we want to, and we could scale it down. So if we want to have it be half the size that it's shown, we could do 0.5, and we can start adding our people. So we want to give them some heat, let's say 120 watts. Now we can place them. Let's say we want to simulate a patient on a bed. We can add a horizontal person, and let's make our table back to its original size. So if we click on it, we can use the window to edit the properties and then select update selected components, and I'll update them. And here we have the same tools: move, copy, rotate. So here's an axonometric view, and it's always helpful to have a front facing view so you could adjust the elevations. So if we want our patient to be on top of the bed, we can move him further up a little bit. And we could do the same with other components. So we can add a chair, add a table, populate our space a little bit. And I'd recommend only doing this with large furniture that could interfere with the airflow in the space. And if at any point we wanted to update a component, we could just click on it, and from the left window, just make our changes and then click on Update Selected Components. And here you'll notice the room heat gains. It shows some heat gain in the space. This is because we added the 200 watts from the radiator and 120 watts for each of the two people. And on the left, Apache shows 0 because we haven't ran our energy simulation yet. We'll revisit this part later on. Now for the last step before we run the simulation is by visiting CFD settings. Here we have the boundary condition where we can assign a temperature for the surface, so any walls and windows. And in the initial conditions, you can set the room temperature for your CFD simulation. Lastly, we're going to generate our grid. We'll go over this in more detail in the next section, but we can start off with a 0.04 or a 0.05 grid, and you want to go to the CFD grid tab and click on generate grid at the left here. This step is very important, otherwise your CFD simulation is not going to run properly. To check that the CFD grid is okay, go to CFD grid statistics and make sure that you're below a 10:1 maximum cell aspect ratio. We'll go over this in more detail in the next section. And now we're ready to run our RNG model.